Hi everyone, welcome to our webinar today. This webinar is a presentation of the Clean Energy States Alliance, also known as CESA, and the RPS Collaborative. And our topic for this webinar is we're featuring two winning programs from the 2016 State Leadership in Clean Energy Awards. And those winning programs are from New Hampshire and Rhode Island. And we have guest speakers with us from organizations in those states to talk with us about their programs. And our host for this webinar will be Val Story. Val is a project director here at CESA. And before I pass this over to Val and our guest speakers, I'd like to go over a few quick housekeeping notes. All of our participants for this webinar are in listen-only mode. That means that you can hear us, but we can't hear you. You have a couple of options to connect to the audio portion of this webinar. You can either call in using your telephone, or you can connect using your computer, mic, and speakers. A very important note, we ask that you please submit your questions as you think of them throughout the webinar by typing them into the question box and hitting send. And for this webinar, we'll be doing questions immediately preceding each presentation. So we're starting with New Hampshire, and we'll do a Q&A directly after that, and then we will have a presentation from Rhode Island and a Q&A after that. So do type your questions in as you think of them. Don't wait till the end. We'll get to as many questions as we can following the presentations. Finally, this webinar is being recorded, and you will find a recording of this webinar on our website at cesa.org/webinars. We will also send you an email with a link to the slides and a recording of this webinar. And with that, I would like to pass it over to our host for this webinar, Val Story.
Great, thank you, Sam. Hello, everyone. Welcome to today's webinar. Thanks for joining us. We're very excited to present to you our first webinar featuring the award winners of the State Leadership in Clean Energy. It's a project known by the acronym SLICE. The SLICE Awards are given out biannually by the Clean Energy States Alliance. We're a nonprofit organization, and we work with our members to address renewable energy policy, finance, and innovation. Our membership, as you can see up on the screen, consists of state clean energy funds and state agencies from around the country who, through CESA, share information and collaborate to accelerate renewable energy deployment. On today's webinar, which is presented in partnership with the RPS Collaborative, that's another CESA project. Next slide. Thank you. The RPS Collaborative is funded in partnership by the U.S. Department of Energy and the Energy Foundation, and it focuses on challenges and solutions for implementing successful state RPS programs. Next slide. The SLICE Awards recognize and celebrate state and municipal programs or projects that demonstrate leadership, innovation, and effectiveness in advancing renewable energy. Winners are chosen by an independent panel of judges who also select the programs or projects based on their replicability and their impact on transforming clean energy adoption in the U.S. Next slide. On today's webinar, we have three guest speakers who will be presenting two SLICE Award programs. I'm going to introduce the panelists at the start of their presentations. We're going to do things a little bit differently today, too. We're going to do questions at the end of each presentation instead of waiting till the end of the webinar. So please think of your questions. You can type them in as the webinar is rolling along, and we will take questions after each presentation. So the first presentation will be by Elizabeth Nixon and Barbara Bernstein of the New Hampshire Public Utilities Commission. They received a SLICE Award for developing rules that govern the metering, monitoring, and quantification of thermal renewable energy credits for eligible renewable thermal technologies, such as biomass, ground source heat pumps, and solar thermal. We're going to learn more about this exciting program next. Let me introduce Elizabeth and Barbara. Elizabeth Nixon is an energy analyst at the New Hampshire Public Utilities Commission. Among other things, she manages New Hampshire's Renewable Portfolio Standard Program and led New Hampshire's rulemaking to incorporate thermal energy into the RPS. Prior to joining the New Hampshire PUC, Liz worked at the New Hampshire Department of Environmental Services, as well as a nonprofit and consulting firms on energy, environmental, and air emissions trading issues. She holds a BS in mathematics from the University of Vermont. Barbara Bernstein will be co-presenting, and Barbara has been part of the New Hampshire PUC Sustainable Energy Division since 2009. She has managed Greenhouse Gas Emissions Reduction Fund grants and currently reviews applications for renewable energy certificate eligibility in New Hampshire's Renewable Portfolio Standard, as well as managing both the residential solar hot water and the residential wood pellet boiler program. Barbara is a graduate of UMass with an MBA and an MRP master's degree. And with that, we can turn it over to Liz and Barbara.
We're having more slides aren't as Nancy. We're having trouble gaining control, screen control. There we go. Okay, this is Liz. Want to thank Val and Sam and CESA and all the judges for presenting us with this award, and we're very excited to share our program with you today. We'll start out with a little background on our RPS program. Our Renewable Portfolio Standard legislation was enacted in July of 2007, and when it was originally enacted, we had 4 classes. The class 1 was new sources and some of the more traditional sources, the wind, biomass, methane gas, and new capacity additions for any operation that began after January 1st, 2006. Then our class 2 is for photovoltaic systems. Our class 3 is for existing biomass, less than 25 megawatts in the landfill gas facilities. And then our class 4 is existing small hydro facilities, less than 5 megawatts. In 2012, our legislature enacted legislation that incorporated thermal into our RPS. This created a class 1 subclass that was specific for useful thermal energy. When the legislation was first enacted, it started with 0.2%, and that was supposed to begin in 2013, but it took us a lot longer to get the rules developed for this program, so the Public Utilities Commission issued an order that delayed the beginning of January 1st, 2014, and so that 0.2% was added into the requirement in 2014. And then in 2013, our legislation again revised the obligation from the thermal and ramped it up a little faster. One of the main pieces of this legislation was to require the PUC to adopt procedures for the metering, verification, and reporting of useful thermal energy output. And metering was one of the key components of this legislation. To begin the rule development, we held several stakeholder meetings starting in August of 2012. As we went along in the process, we realized that we needed some help on this, so we hired a consultant. And by September of 2013, they issued a draft report with a proposed metering and verification methodology. The primary feedback from stakeholders was it was very complex and we wouldn't get any facilities that would be able to be eligible because we had them metering not only the useful thermal output but also any parasitic load that would be needed to run the facility. So we had them revise the methodology and propose draft rules in April of 2014. Now, as I mentioned earlier, the program started in January 2014 when utilities had to meet those obligations. So the Commission issued an order in the summer of 2014 that said use those proposed rules as guidance, and we would allow facilities to get recs for that period until the rules were final. So finally, in December of 2014, the rules were final, and we started to begin getting applications, and we allowed those recs back to the beginning of 2014. I know this is hard to read, but basically it's just to give you an idea that in 2014 the obligation was 0.4%, and as I said, it ramps up so that by 2023, it's 2% of electric load. And this slide shows the megawatt hour equivalent. So it starts out about 43,000 megawatt hours up to over 240,000 megawatt hours. One of the key provisions of this legislation was the definition of useful thermal energy. And I'm just going to read it. Basically, it's the renewable energy derived from Class 1 sources that can be metered and is delivered in New Hampshire to an end user in the form of direct heat, steam, hot water, or other thermal form that is used for heating, cooling, humidity control, process use, or other valid thermal end-use requirements, and for which fuel or electricity would otherwise be consumed. As you can see, that definition had a lot into it, so that was the driver for what our rulemaking had to include. As Val mentioned, the eligible technologies were listed in the legislation. It's solar thermal, it's geothermal ground source heat pump, and thermal biomass technologies. And that also includes the biomass combined heat and power that can get both thermal and electric rec. The legislation requires that the facilities have to have begun operation after January 1st, 2013. The biomass facilities have to meet stringent emission requirements. The PM is listed, as you can see, depends on the size of the system. NOx, again, for the large sources, and then for the smaller sources, it's 100 million BTU per hour or less must meet best managed fit practices, which is the way to determine that is to require annual tune-ups and to determine the combustion efficiency. And then for the combined heat and power facilities, they also have to meet electric emission requirements to meet their electric rec. So one of the key factors, again, that was one of the complicating factors, was how to do this metering and measurement. And what we had to do was figure out where we're going to draw the box around the whole system. So the determination was made that we would look at the useful thermal output before the delivery of the heat to the distribution system. And the measurements for the different systems vary. For air and water type systems, it's based on flow, temperature, and the specific heat. And for steam systems, it's based on flow and the specific enthalpy and the temperature, meaning the temperature and pressure. The metering equipment has to meet an accuracy standard. And the U.S. does not have a standard yet for heat meters. It's in process, and I think it's probably very close to being finalized at this point. But we had to look at the European standard, and that's the EN 1434. So that's the accuracy standard that must be met for the air and water-based systems. For the steam systems, the accuracy has to be plus or minus 3%. And then for an alternative methodology, it can be plus or minus 5% or better. But in that case, your RECs will be discounted. And again, we have an alternative methodology that you can do for metering. Now, for smaller sources, stakeholders said that it would be too expensive to install these meters, but our legislation requires that they have to meter something. So we've allowed for them to do some sort of parametric monitoring and metering. So in other words, they can look at metering the operating hours or some other factor that can be used in the calculation. For the solar thermal, we meter the operating hours of the pump and then look at the SRCC rating for that collector and then take into account any shading and orientation losses. For geothermal systems, the ground source heat pump, again, we look at the operating hours of the pump and then look at the heating capacity and the coefficient of performance. And then for thermal, the small thermal biomass, again, we look at operating hours and the fuel input, but it needs to be verified with purchase records. One condition that we weren't sure what level to establish was a threshold between small and large. and Barbara will get into this a little more, but that's one thing that we're looking at to possibly change. But at this point, the dividing line is 200,000 BTU per hour of heat input. Now that was all about measuring the thermal output, but to actually get to the REC calculation, you take the thermal output, but then you have to discount it for the metering accuracy, and then also discount it again for the large sources for any of the energy that was used to create the heat. And then the statute required to use the standard conversion of 1 megawatt hour equals 3.412 million BTU per hour, or 1 megawatt hour equals 3.412 million BTU. Instead of having the complicated parasitic load discount factors that I discussed earlier, the consultant helped us come up with default parasitic load factors, as you can see here, 3% for solar thermal, 3.6% for geothermal, and 2% for thermal biomass. The sources have the option of actually metering the parasitic load if they choose. And again, these are only for the large sources. So the legislation required that the thermal output be verified and reported. So as I mentioned, they could go back to January 1st, 2014, or whenever they began operating. And because we don't have experts on staff, all the systems must be verified by a professional engineer. And then our requirements also require that an independent monitor must inspect the facility initially. And then the independent monitor is the one that reports the information to the NEPL GIS. Now, the independent monitor for thermal RECs is somewhat different than electric RECs. The requirements of the monitor, they overlap somewhat, but for geothermal, you can also have additional certifications for solar thermal. And with that, I'll turn it to Barbara.
Good afternoon. It's a pleasure to be with you. This is Barbara Bernstein, and I am in charge of reviewing the applications for REC eligibility. And for our thermal program, to date we have certified 18 facilities. 12 of those are biomass, and then 6 are geothermal. And that's for a total of just over 10 megawatt equivalent, which we're pretty happy about. In addition, I do have some applications. I have 2 in review right now for geothermal and another large biomass facility that is currently trying to work out metering options. So there definitely are benefits to this program. First of all, there's the tremendous impact it has on positive impact on our local economy. The Northern Forest Center reports that 78 cents of every dollar we spend on imported fuel, and that's a fossil fuel, and that's $6 billion annually, leaves the region. Every dollar that we spend on biomass supports our economy, especially in the northern tier of our state that's been severely impacted by the loss of the pulp and paper industry. So we've been able to keep a lot more of our dollars here, which is a tremendous benefit. It also provides an additional revenue stream for participants, which they're all thrilled about. Definitely we've had environmental positives for this as well. Certainly helps to support forest health, because the wood that is gathered for this is wood that needs to be cleared to keep the forest, the old growth, growing and healthy. So that's a tremendous benefit. And the units that are going in are definitely more efficient. They're using these renewable technologies. And as Liz pointed out earlier, there's more stringent emission standards that are required as well. just to give you an example, we have one biomass facility here in New Hampshire that displaced 280,000 gallons of number 2 fuel oil just over the past 2 years, and they replaced that with 7,043 tons of wood chips. They bought those wood chips from a local vendor, greatly supported the local economy, and they've generated approximately 7,800 thermal RECs over the past 2 years, which definitely translate into some income as well. So lessons learned. First of all, I think that we feel pretty confident that RPS programs can include thermal and provide positive economic benefit to the region. Some things that we're still working on. We have yet to receive any applications for solar thermal. We also haven't had any applications for biomass systems that are under 191,000 MMBTU per hour. So we've asked folks what needs to change, and one thing they've talked about is that we need to simplify the administration. That's something that we need to continue to work on because we're very concerned about how we might do this and still maintain the integrity that we need to have this as part of the renewable portfolio standard. So those are things that we're going to continue to be looking at. Also, the application that we put together with our consultants, as I've been working on getting these systems approved, I've made some modifications to that application. So if any of you are out there and are interested in getting that, please let me know, and I'll be happy to pass that on to you. So with that, I guess we'll go to Val for questions. Oh, there's our contact.
Thanks to you both. If you haven't had an opportunity to type in your questions, go ahead and use the questions dialog box now, and we will try to get to them. Let's start off with some questions about the T-RECs, the thermal RECs. How does the T-REC differ from Class 1 power RECs?
It's a subclass of Class 1. So, for example, in 2016, the total Class 1, trying to look back here, in 2016, the total Class 1 is 6.9%, but of that, 1.3% has to come from thermal. So what happens is, even though that the thermal is, measured on a BTU basis, it's converted to megawatt hour.
Great. Can you talk a little bit more about how the T-RECs fit into other state or federal plans, such as the Federal Clean Energy Plan compliance or other regional frameworks like Reggie?
Not really sure what to get at with that. Well, it just really fits in as a part of our RPS. As far as the regional framework, the only thing that it fits into regionally is to the generation information system of NEPOL, which is our power grid. We haven't tried to dovetail that into Reggie at all, because in New Hampshire, Reggie is only available for energy efficiency, and it has been pretty restricted as to what that can be used for. And overall, as we mentioned, the emission requirements, we do have reduced emissions from these sources, so ultimately it will probably tie in, but because Reggie is our driver, we don't have to look at it specifically from the RPS.
Okay, great. Thanks for those clarifications. Another question about the T-RECs. Is the market liquid enough to support long-term contracts with utilities?
We hope so. It seems to be the case that is happening. And one thing that we've seen is that and Charlie Niebling has worked with the U.S. Forest Service to get a grant to purchase those RECs over a long term, so that sources can have the money up front to use it as capital towards the initial investment. But in general, I would say that a lot of our utilities don't enter into long-term contracts for any of their RECs. It really is a year-to-year situation.
Okay. And I believe you mentioned an average value. What is average value, or what is the value of the TREC? Is it the same as for electric RECs?
The alternative compliance payment rate is about $25 per megawatt hour. So it's less, because our class 1 electric RECs is about $55 a megawatt hour for the ACP. So we're guessing that the RECs are selling at about close to, or obviously below, that alternative compliance payment rate.
Have you seen any district heating projects that have arisen as a result of the TREC program?
Not yet, but I'd be thrilled to see one.
There's actually a small-scale one. I'm not sure if it's been certified yet, but we actually gave a grant to the Holderness School, and they put in a biomass district heating system, and if they haven't already, we'll be applying for RECs and getting RECs. But that's on small scale. That's not like citywide.
Okay. Great. Let's move on to some questions about metering, monitoring, and verification. Are the PEs trained at all? Have you had to provide, what has been your experience with PEs?
Well, the engineers have their own specialization, and the engineers that have participated to date have had whatever training they need to be able to do the analysis. New Hampshire, we don't have an engineer on staff, so we rely on the engineer stamp as the verification that the systems are accurate.
Okay. Let's see. There is a question about the biomass resource. If there is any awareness or any requirements about non-waste wood, and if there are any concerns about this sector being a growing source of greenhouse gas emissions.
Val, could you repeat that again, please?
Sure. Just a question about the biomass resource and how to control the wood type that's going into these facilities, and given the growing awareness that non-waste wood is a major and growing source of greenhouse gas emissions, is there any verification about the fuel?
No, not at this time.
Yeah, we don't have any requirements related to that.
Let's see. There are a couple of questions about geothermal systems. And let's see, there's some acronyms here that I'm not familiar with, so perhaps you are. So for geothermal systems, the coefficient of performance and the HC were the values the manufacturers reported ISO values.
It's the ASHRAE values on the specification sheet.
I'm sorry, will you say that again?
It's I'm looking at some of my notes here. It's the it's the AHRI values that are on the manufacturer specification sheet.
Great. Okay. Thank you. Jumping back to biomass, you mentioned possibly changing the small and large designation. If you were going to change that threshold, would it be for greater or less than it is now, and what is the rationale for the change?
Well, I think that I'm going to give that famous accounting answer. It depends. Some of the things that we need to look at are what kind of standards do we need to have in order to make sure we keep that integrity. As it stands now, we've just done a review of our wood pellet boiler program, and the industry folks that came and participated in our tech session said that really any system smaller than 500,000 BTUs per hour couldn't really swing the meter and everything else that they needed to do. We've added an adder for metering into our revised program there. So we're hoping that maybe we'll start to see some lower thresholds come in. But again, that's one of those things that we're going to have to see what helps and what doesn't, and we're hoping to meet with industry representatives in the near future to try to start working on that.
And I'll add to that, I mean, what Barb is referring to is giving them added incentive as part of our rebate program. But as we were developing this program, the original threshold was, I believe it was 100 or 150,000 BTU per hour, and based on feedback from stakeholders at that point, that's when we increased it to 200,000. And we're told at that point from some of the stakeholders that was a sufficient level. But as Barbara said, we'll continue to review that.
Okay. Thank you. What other states, or have any other states approached you, and do you know of other states considering the adoption of TREX?
Massachusetts has been looking at this for a while, and I believe that they just issued proposed requirements. And Oregon just recently got in touch with us, and I believe they're holding a stakeholder meeting on Friday.
Oregon?
Yes.
Great. Thank you. All right, let me just scroll through here.
Some other states have had thermal as part of rebate programs, but where ours is different is that the key thing is it's a subclass of our RPS, and it has the metering requirement.
Back to biomass emissions. What was the heat input cutoff for biomass emission for the biomass emission standard for PM at 0.02 pounds per micromillion BTU?
Could you go back to that slide, if you don't mind?
Yeah, Sam, could you go back to that slide?
And while she's going back to that, could you repeat the question again?
Sure, the heat input cutoff for biomass emission standard for PM.
The heat cutoff, for 3 to 30 million BTU per hour, it's 0.1 pounds per million BTU, and for greater than 30 million BTU per hour, it's 0.02.
All right, the slide is up, and hopefully that will answer your question. Just in case you hadn't heard, this webinar is being recorded and will be available on our website. And final question, advice for states considering TREX. What are the most difficult issues you've had to address in developing the policy?
Very good question. And that was the most difficult issues that we've had in developing this? Is that what the question was?
Yeah, advice that you might have for another state considering implementing T-REX as part of their RPS. What are some of the more difficult issues you've had to address in developing your policy?
One thing I would say is we've had a champion for the thermal REX from day one. So Charlie Niebling from the biomass industry has really pushed for this, and we've gotten, and then the geothermal industry was really supportive and helpful and pushing us. So they really were interested in seeing this get completed to help encourage growth in those industries. In terms of the development, because we're not thermal experts and not engineers, it's been difficult on the technical end for us, and that's why we ended up hiring a consultant. So it's helpful to have those experts at hand. And then as Barbara mentioned, we need to look at the administration of this and from the facility perspective, because we're hearing from them that it is costly to put those meters in. So we're trying to be flexible and be able to modify as we grow over time.
And I would add that I think another real difficulty for us has been that we were not able to add any technical staff to be able to run this program. So that means that we have to rely on the licensed engineer for the review. And it's not that I don't trust engineer stamp, it's just that I wish that we had that expertise that was more readily available.
Great, thank you very much. Thanks for all the information. Congratulations on your SLICE award. Thanks to everyone for all your questions. We are now going to move on to our next presentation. The next presentation will be given by Danny Musher from the Rhode Island Office of Energy Resources. They have received a SLICE award for their System Reliability Procurement Solar Distributed Generation Pilot Project. The pilot project explored how distributed PV could provide value to Rhode Island's electric grid, and the project sought to understand what the various costs and benefits of solar distributed generation is, particularly in its ability to reduce peak loads on the grid. Danny Musher, he's the Chief Program Development Officer at the Rhode Island Office of Energy Resources. He focuses on clean energy policy and planning issues, including electric system reliability, grid modernization, and thermal efficiency and renewables. He was the author of Rhode Island's first data-driven state energy plan, which was formally adopted last year. He graduated magna cum laude from Brown University in 2010. Danny, we can turn it over to you now.
Thanks, Val, and really happy to be here today, and thanks to everyone for listening in. Just like to take this opportunity to thank CESA and all of the staff over there for the invitation to present, and more generally for spearheading the SLICE initiative, which I think is a really great effort, and we're certainly appreciative of the opportunity to be recognized for our work and the opportunity to hear about the good work that's being done in other states like New Hampshire. So just really quickly about our office, we are the lead energy policy agency for the state of Rhode Island, and we work on a variety of clean energy planning program and policy initiatives. We do work closely with diverse partners in and out of state to achieve our energy, economic, and environmental objectives while advancing the state's position as an emerging leader in the national clean energy economy. So today I'm going to be providing an overview of our pilot that we received the SLICE award for. It's the System Reliability Procurement Solar Distributed Generation Pilot Project, which I know is quite a mouthful, so I'll be using some acronyms to make things easy here. The pilot's been a multi-year effort that focuses on what I think is a really exciting growing nexus between solar PV and distributed energy resources more generally, with the world of utility distribution planning, which is, not necessarily known for being glamorous, but it's becoming more glamorous as time goes on, and people are seeing some opportunities there to integrate distributed resources. So as most folks on the phone are familiar with, the electric utility industry is in the midst of a fundamental transformation as it transitions to a distributed energy future. And one critical key to unlocking this future is better understanding how we can effectively integrate DG as part of this evolving electric grid. And one aspect in particular, I think, for distributed energy resources and for solar is how it could actually lower distribution costs by deferring or potentially even avoiding infrastructure investments, and figuring out how to orient and configure the solar in order to do that. So this pilot was looking at just that question. We had a specific community in our state where a distribution substation expansion was being proposed, and we were investigating whether solar resources could, A, be effectively recruited and deployed at the local level in that particular area, and B, whether they could provide verifiable and dependable peak load contributions to meet that distribution need. And so our preliminary answer was that yes, they can. A little bit of context, I'll provide some background on what we mean by system reliability procurement, which is where the idea for this pilot first originated. So Rhode Island has a unique system reliability procurement law that is actually a provision of our all cost-effective energy efficiency statute. And this was first passed in 2006, so I think it was a pretty forward-looking aspect of Rhode Island policy. The SRP component requires our state's dominant electric utility, National Grid, to consider cost-effective non-wires alternatives, or NWAs, in electric distribution planning. So NWAs would include cost-effective energy efficiency, distributed generation, demand response, targeted at peak loads on the grid. And so under SRP, utility planners need to evaluate these NWAs for the potential to cost-effectively defer or avoid certain traditional poles and wires investments. And so what we had was we had already in place this novel policy tool that Rhode Island could draw upon and build on for integrating solar into the distribution grid in a cost-effective manner. So to date, this is what SRP looked like. National Grid was conducting a pilot SRP project called Demand Link. This was designed to address a localized electric load constraint in the towns of Tiverton and Little Compton, which are two towns along Rhode Island's eastern border with Massachusetts. The constraint that we have in this pilot area is in the late summer afternoon when the local system is experiencing particularly high levels of electricity demand. So Demand Link is focused on promoting geo-targeted customer adoption of energy efficiency and demand response to mitigate that peak. And the ultimate objective is to defer the construction of the original proposed wire solution, which is nearly $3 million substation feeder that was proposed in, or that was going to be needed in 2014. So we've already experienced a little bit of deferral for that project. So then our office stepped in because for quite some time, stakeholders, including us, were really interested in exploring how solar could complement Demand Link, the energy efficiency and demand response, which was not being considered under National Grid's pilot. So we proposed a coordinated pilot effort, the SRP Solar DG pilot, and this was looking at how solar could also potentially contribute towards addressing a load constraint. So we partnered with National Grid and commissioned a study by Peregrine Energy Group, which approached the question of pilot design and helped better define the parameters for how we were going to be going about and enrolling our solar resources. Try to answer questions like what's the total nameplate capacity of solar we would need to achieve a certain kW of peak load reduction. Based on that nameplate capacity, what would we reliably be able to expect from solar during those peak hours? And based on that information, how would we be structuring incentives and programs to not only enroll the solar, but to really be deploying them in the configurations and orientations that would be necessary for the peak reductions? So, westward-facing systems that generate more in the afternoon, and orientations that might not necessarily be proposed by companies on their own under existing structures like net metering. So here's where we landed with the pilot design. The chart that you're seeing here is displaying the portfolio of solar resources that we were looking to enroll. You can see on the first row the gross or nameplate capacity of the different solar systems that we were looking for, and then an associated metric of distribution contribution percentage. The distribution contribution percentage, or DCP, is a calculated value that's representing what's the actual kW capacity available at the local system peak. This was calculated based on hourly solar data and hourly load data from the substation to understand historically on the peak days what amount of solar would have actually been available during those peak hours. So you can see in the last column that in order to get 250 kW of distribution contribution capacity, we would need 520 kW of nameplate solar according to these different configurations. And so the configurations that you're seeing there, the grid support solar fields and the Solarize systems for residential and commercial, we use two different recruitment strategies to recruit those systems. The grid solar fields were larger systems. We conducted just an open solicitation for competitive proposals from solar developers. The goal there was really to enroll a smaller number of larger projects that could provide the bulk of the capacity that we needed. And then the second strategy was the locally based Solarize campaign, which is for those second two columns there. And many folks on the phone might be familiar with Solarize initiatives, which have been conducted very successfully by several CESA member states and across the country in several states. The Solarize efforts are emphasizing community engagement techniques and use competitive tiered pricing to promote targeted adoption of solar. The tiered pricing helps drive down the cost for all the participants by leveraging economies of scale. And from our perspective, I think the goal of Solarize was really to help diversify the solar resource portfolio, both geographically and in terms of system orientation. So we could have a couple of larger systems, but we wanted to make sure that due to intermittent cloud cover or other weather factors, we would be able to diversify. And it would also provide quicker deployment of the initial solar capacity because residential systems can go through the permitting and interconnection processes in construction faster than commercial projects. So I'll talk a little bit about each of those recruitment strategies. First, the solar solicitation. So an important goal of the pilot that we were working on was to make sure that we could seamlessly integrate and leverage existing programs, because what we were looking at here was not to create a completely separate incentive program, but to be able to target our incentives on the incremental distribution value that was being provided by the solar systems. So for the open solicitation, we designed the pilot to work in conjunction with our state's Renewable Energy Growth Program. And this is a program that provides long-term performance-based incentives for solar and other renewable projects over a long period, like 15 or 20 years. And so for our pilot, we simply required the projects to bid into this existing program, and they would be awarded a certificate of eligibility through that program. And then we offered an additional competitively awarded grant that would compensate those applicants based solely on the incremental costs that the developer might incur to maximize the project's benefit to the distribution system. So this might be either installing tracking technology, which could add to the cost, or orienting a ground-mounted system westward, which would reduce the project revenue. So we wanted to just basically create a grant that would help these projects compete on par with a regular traditional south-facing system that would be bidding into the program. For the Solarize initiative, we did offer traditional rebates for the systems for south-facing systems, but we also did want to enroll those west-facing systems as well to provide the benefit in the late afternoon peaks. So we developed an incentive design that would help broaden eligibility for systems, and it would improve the customer economics for those west-facing roofs. So this was a sliding scale incentive for the westward-facing projects. And as you can see in the graph here, which is kind of small, but gives you an idea of how the rebates were structured to be based on the minimum of either the lost revenue that the customer would experience due to the lost net metering revenue due to orienting their system away from south. So net metering is based just on total kWh production. When you orient it south, you get less kWh production, so we wanted to compensate them from that. Or the incremental value that the project was providing to the distribution system. So in many cases, the value of the lost revenue exceeded the value that the small-scale solar systems were providing to the distribution system. So we did take that minimum. But we did see great uptake of these incentives through the Solarize program, and had a lot of interest in customers and got a lot of west-facing roofs out of it. So we were happy about that. So overall pilot results. I think we landed in a great place. The pilot was successful. We exceeded our goals for solar enrollment. 735 kW, which surpassed our original goal of 520. The solar solicitation received a positive response. We awarded a proposal for a single-access tracking system, so we were really excited about that. Because we don't see very many single-access tracking systems in this part of the country or in our state, but we did get a response from the marketplace for that, and that particular system configuration is providing so much contribution during the peak periods that we only had to make one award to achieve our goal for peak capacity contribution from the large system. That was pretty cool. And then through the Solarize system, we engaged with over 260 local residents through 6 community events, and then ultimately had a great uptake of 67 customers signing contracts for solar projects. And we've actually seen very little attrition from that due to our Solarize contractor who had a unique sales model that really encouraged people to sign up who were committed to installing their system. So that was another positive aspect. And then finally, the solar that we installed is going to be, it's estimated to contribute 360 kW of peak load reduction and potentially add on 2 to 4 years of infrastructure upgrade deferral. So National Grid, through their demand link initiative, is looking for a total of 1 megawatt of peak load reduction. So this is exciting because solar is going to be providing over a third potentially of that peak load reduction. So it's a good story. So what worked and where do we go from here? I think number one really is the fact that we've established this proof of concept that solar can be used as a non-wires alternative and that it can work. The implementation strategies that we used in terms of the open solar solicitation and the Solarize efforts, those are strategies that can be replicated or adopted by other jurisdictions or utilities, so it's replicable. I think we demonstrated that you can have a constructive partnership between the State Energy Office and an electric distribution company on the nexus between solar deployment and grid planning. We've seen a lot of stories regionally and across the nation where the interests don't necessarily align, but this was one where I think we had a good story there. We collaborated with Grid throughout the pilot conceptualization, through the scoping and implementation, and now after the fact we are coordinating on an evaluation study that's going to be verifying the performance and the contributions of the solar systems during the actual summer peaks, both this year and next year. We did outfit all of the systems with a data acquisition system, which has the capability to distinguish between in-home energy usage and solar production. So that's going to be key, and we're going to be able to look at the customer patterns of usage and how they align or don't align with the solar production and how that relates to the loads on that particular feeder and substation. And then I think finally what is maybe most exciting is what this might entail for the future formal role of solar and National Grid's distribution planning and system reliability procurement efforts more generally. We think that the results of this pilot could directly inform nascent efforts at our PUC to investigate the changing distribution system. And this is a docket proceeding that's going to focus on creating a common cost-benefit framework for all of our state's energy planning, investment, and policy initiatives. So really some exciting stuff, and we're looking forward to seeing where it goes, and happy to answer any of your questions.
Great. Thanks, Danny. Just a reminder to type in questions if you have not had an opportunity to do so yet. Danny, could you review once more the infrastructure deferral as a result of this particular project?
Sure. So the project is a $2.9 million feeder upgrade to a substation. So I believe it was either one or two feeders that was proposed by National Grid to handle increasing load in that area of the state, so that the load is increasing at a greater rate than the statewide average. And their distribution planning team, under normal circumstances, would have built this additional feeder capacity. So that was the result. That was the impetus for the demand link and original SRP efforts and the solar efforts.
And so now one of those, did you say it was a substation, is going to be deferred for a number of years?
Sure, yeah. One of the learnings that we had was that originally this was proposed for 2014. The load was, continues to increase, but was stable enough that they did not have to build it in 2014. So it already has been deferred for, I believe, a year or two. So that's in part due to the energy efficiency efforts and demand response efforts, but also due in part to the fact that the worst case scenario of load never materialized. I would have to get someone from National Grid to be able to answer this in more detail. But now what we believe will be the case is that with the solar going up and those peak contributions could be enough from National Grid's distribution planning team perspective to potentially contribute 2 to 4 more years of deferral in the future, in addition to the energy efficiency and demand response efforts.
Great, thank you. You mentioned the value to the distribution grid in addition to deferring maintenance. How is value to the grid calculated? The value of adding west-facing solar and more solar to reduce peak impacts.
So the avoided cost, there's an actual dollar value associated with the substation upgrade, and you get that deferral value, and then for a few years, and then the substation needs to be built, and then it reverts to the statewide average for T&D deferral. So you're getting that benefit, a specific infrastructure deferral benefit for a few years, and then you would just get a general T&D benefit deferral benefit, sorry.
Great, thanks. A clarifying question here as to the location of the PV. Were they downstream of the substation?
Yes.
Is there any preliminary data on the impact of the west-facing installations? It sounds like this is something that you're studying now.
Yeah, we are studying it now. So we don't have any data yet, but we are looking forward to getting it. And I think we'll probably be getting some actually right now. It's getting pretty hot outside, so.
Were costs higher then for installing the west-facing panels, or for the program overall?
Wait, so, can you say that question one more time?
Sure. From a cost perspective, was this program, did it cost more than a traditional Solarize program, let's say, because of, for example, targeting west-facing homes?
No. I mean, we were providing additional, I mean, yes, in the sense that we were providing additional incentives for orienting westward, but not from an installation perspective, no. There wouldn't be any additional costs. But we were, you know, the west-facing systems were eligible for the regular state rebate and then an additional incremental rebate that was really just, like I mentioned, really just compensating customers for lost net metering revenue that they wouldn't have gotten compared to a regular south-facing, an identical south-facing project, or the benefit, the calculated benefit that they would be providing to the distribution system.
Great. You mentioned a unique sales model. Can you say more about that?
That's a good question, and my counterpart in the office here, Shauna Beeland, did a fantastic job coordinating the Solarize campaign, and she'd be able to answer better than me. But I believe that the company was basically providing better information about costs up front to the customer, so the customer didn't get sticker shock later down the line when they actually, you know, they had typically, I guess you'd have a site visit and then you'd get information on what the cost of the systems would be later, and I think this particular vendor was able to provide that information earlier in the process, which resulted in the leads that we got being leads that were actually interested in following through with the project.
Great, thanks. We have a technical question. Do you know the size of the area on each feeder? Was it a city block or was it larger? And do you know how many customers were on each feeder?
I think that there's about 5,000 customers in the on the area served by that particular substation. It's mostly residential, with only a few smaller commercial customers. It's more of a rural type area. Sorry, did that answer all the question? I didn't catch the entire part of it.
Yes, I believe the size of the area for each feeder and how many customers.
Oh, yeah, I'm not sure for each individual feeder, but it's 5,000 customers for the entire area, so relatively small. But that was one of the challenges, was being able to, A, recruit enough customers to get enough solar up there, and B, being able to find, although it is more rural, being able to find land that would be suitable or that there would be customers who'd be interested in hosting a larger project. So we were glad we were able to find that.
Great. And our final question for you, Danny, any future plans to replicate this pilot project, or would you look to other technologies, and could other technologies have the same or greater impact, renewable energy technologies on the grid and infrastructure deferral?
It's a great question. For the second part, I will say that we did examine whether storage would provide value to the package of solar resources that we were proposing when we originally looked into pilot design, and what we found was that it would just be a lot more cost effective to slightly increase the amount of the number of solar systems that were oriented westward, or just increase the capacity a little bit, and would provide the same reliability benefit to the grid in place of doing storage, which would be much more expensive. So you could obviously get a lot of other benefits from storage, but in terms of purely the deferral benefit, it just made sense to put in a little bit more solar. In terms of replicating this, right now we are undergoing a 3-year revision process to the regulations that govern our SRP process, and there's going to be a lot of thought that's put into this. We're working closely with National Grid and stakeholders to really think through how we can take SRP to the next level. And part of this, I think, will involve changing some of the, broadening the eligibility for what would be contemplated for an NWA, so that NWAs don't necessarily have to defer an entire single infrastructure project, but could reduce the size of many, potentially. So National Grid has an annual capital investment plan where they look at upgrading a number of different substations and feeders around the state. Instead of upgrading 4 feeders, could they upgrade 3? So that type of idea. And then we hope that right now there is a really broad list of technologies that are eligible, including storage, demand response. I'd have to look it up, but it's a very broad list. National Grid has really only been using the energy efficiency demand response, but we think that after having done this solar initiative, that it will hopefully provide the basis for being able to draw on that for future projects that National Grid itself would administer, in conjunction with some of the other renewable energy programs like renewable energy growth that they're already administering on their own, or potentially new technologies as well down the line, like storage or otherwise.
Great, thanks. We look forward to hearing about the data you're able to gather over the next few years and seeing how the pilot has contributed to infrastructure deferral and strengthening the grid. Thank you, and congratulations on your SLICE award.
Thanks, Val.
Sure. So just a reminder, this webinar has been recorded. It will be archived on CESA's website. You can access it there in a few days. Thank you, everyone, for listening in and for participating. And thanks to all the panelists and to Sam for all your work today.